In this video, you will learn how to find the limit at infinity. So first theorem is for any polynomial function as x approaches to plus or minus infinity, the term with the highest power of x determines the limit. So in a nutshell, the theorem says any polynomial function as x approaches to plus or minus infinity, the term with the highest power of x determines the limit. Okay, so let's see first example to illustrate the theorem. So find the limit of f of x at plus and minus infinity. So what is the term with highest power of x here? So it is 3x squared, right? And the theorem says when the highest term with the term with the highest power of x, this determines the limit. So this will determine the limit for us. So you can substitute this x by infinity. So we take so the limit as x approaches to plus infinity of x, this is equal to, so we took 3x squared. Now we substitute 3x squared by plus infinity. So this is equal to plus infinity, because infinity squared is infinity, it gets bigger, and 3 multiplied by infinity, it gets much more bigger, okay? Now we find the limit for 3x squared at minus infinity. So we substitute x by minus infinity, x squared. So we'll get minus squared. So all of you knows when you have minus squared, this is equal to minus multiplied by minus. This is equal to positive plus. So we get positive infinity. Let's see second example. So find the limit of f of x at plus infinity and minus infinity. So again, the theorem says what is the term with highest power of x? It is here we have x to the power 5, here we have x to the power 1, here 8, we don't care about constant number. So the highest one here is minus 4 to the x to the power 5, right? So we take the limit as x approaches to infinity for minus 4 x to the power 5. So we substitute x to the power 5 by plus infinity. Plus infinity to power 5 is plus infinity, but it is multiplied by minus 4, which is equal to minus infinity. Okay, so the sign minus the sign of 4, it is minus, that's why it changes the sign of the positive infinity to minus infinity. Now let's find the limit as x approaches to minus infinity for minus 4x to the power 5. Now we substitute x to the power 5 by minus infinity. So minus infinity to the power 5 is odd number, so it will remain as a negative infinity. Now minus 4 multiplied by minus infinity, it is equal to plus infinity. Let's see second theorem. So for any rational function p of x over q of x, so where p of x and q of x are polynomials. Polynomials means like this one, 3x plus 5. This is a polynomial function, and x squared minus 1, this is also a polynomial function. As x approaches to plus or minus infinity, the limit is, so here is important, the limit is determined by the ratio of the leading terms. This means the ratio of leading terms means the terms with the highest power of x, okay, in the numerator and the denominator. Meaning, when you have a rational function like this one, p of x over q of x, and p of x and q of x are polynomials, so when x approaches to plus infinity or minus infinity, the limit is determined by the ratio of the leading terms. This means the terms with the highest power of x. So let's see first example to illustrate this theorem. So find the limit of f of x at plus infinity. Before to solve the example, there is something important to talk about. So we have two properties. When you have a number over infinity, the infinity can be positive infinity or minus infinity. So this is equal to 0. Or when you have infinity over a number, this is equal to infinity. Okay? So let's solve the example. First example. So what is the term with the highest power of x here? Actually, we have only one x. The constant numbers, we don't care about them. So we have 3x. So we take 3x. Okay? Then for the denominator, we have x squared. So we take x squared. This x will go with this. We have x squared here, so we'll have only one x will remain, and here this x will disappear, and we'll get 3 here. So 3 over x. Now we find the limit of 3 over x. So find the limit as x approaches to infinity plus infinity, 3 over x. So we substitute x by plus infinity. So you see, in this case, we are in this case, number over infinity. So we have 3 over infinity, which is equal to 0. Let's see second example. So find the limit of f of x at plus infinity. So as we said before, the theorem says, what is the highest, what is the term with the highest power of x for the numerator? Here we have x to the power 1, here we have x minus x to the power 3. So the highest power of x here, it is minus x to the power 3. So we take it, and so we take minus x to the power 3. And here we have x to the power 5. So x to the power 5. Then we'll get, this is equal to minus 1 over x squared. Now we find the limit as x approach to plus infinity for minus 1 over x squared. This is equal to this one here. Okay? So this is equal to, we substitute x squared by plus infinity, and in this case we are again number over infinity is equal to 0. So minus 1 over infinity is equal to 0. Let's see third example. So find the limit of f of x at minus infinity. So we have 4x, so we take, minus 4x, okay, because we have only one x here, so we take the minus 4x directly, and here we have x, so we take x directly, so this x will disappear with this x, and we get, so the limit x approaches to minus infinity for f of x, this is equal to minus 4. Let's see fourth example. So find the limit of f of x at plus infinity. So as we said before, we always follow the same theorem of rational functions. So what is the term with the highest power of x here? So we have minus x to the power 5. And here we have x to the power 2x to the power 2 and x to the power 3. So the term with the highest power of x, it is x to the power 3. So we take this one and this one. Minus x to the power 5 and over x to the power 3. This is equal to minus x squared, because this will disappear with this, and we get minus x squared. Then we find the limit for minus x squared, so minus x squared. So find the limit as x approaches to plus infinity for minus x squared. We substitute x squared by plus infinity. So minus multiplied by plus infinity squared, it will be minus infinity. Let's see fifth example. So find the limit of f of x at minus infinity. So we follow the same rule. Don't worry when you have many x with different powers. So you just check what is the term with the highest power of x. Here I have 3, here I have 5, here I have 7. This is the highest one. So I take 2x to the power 7, and for the denominator we have x to the power 6. It is the term with the highest power of x, so we take it, and this is equal, this will disappear with this, so 1x will remain, so we'll get 2x. Then we find the limit of 2x, so limit as x approaches to minus infinity for 2x, so we substitute x by minus infinity, 2 multiplied by minus infinity, it gets larger and larger to minus infinity, so it is equal to minus infinity. Let's see third theorem. So when you have f of x is equal to the square root of g of x. This is a radical function. So what you will do is, if you want to find the limit of f of as x approach to plus or minus infinity for f of x, so you will take the limit of g of x. So let's directly see first example to illustrate this theorem. So find the limit as of f of x at minus infinity. So what we will do is we will look at the 1 minus x, and we'll deal with this as it is. If it is polynomial, I will follow the first theorem of polynomials. If it is radical function, rational function, I will follow the second theorem we saw, so and so on. So here it is polynomial function, right? 1 minus x. So here we have x, only one x, and it is the term with the highest power of x. So what we'll do is we'll take directly minus x. So limit x approach to minus infinity. So we take the square root of. So this minus, we didn't touch it. Then x, we substitute it by x. We substitute x by minus infinity. So minus multiplied by minus, we get positive infinity. Okay. Let's see second example. So find the limit of f of x at minus infinity. So what is the term with the highest power of x here? It is x squared, right? So what we'll do is we'll take the square root of x squared. So now we'll find the limit as x approaches to minus infinity. So we substitute x by minus infinity. So minus infinity squared is equal to positive infinity. Let's see third example. So find the limit of f of x at minus infinity. So here you see, here we applied the theorem of polynomials, but here we apply the theorem of rational function because it is a rational function, right? So we have 4x here as it is the term with the highest power of x, so we take 4x, and here we have x, so we take x. Now this x will disappear with this x, and the limit as x approaches to minus infinity, so it is equal to, we take the square, the constant numbers, and does not change if it is minus infinity or positive infinity, so the square root of 4 is equal to 2. Okay. Thank you for watching, and hope to see you in the next video.